Our lab is a very electrochemistry focused lab, but we have a very multidisciplinary approach. We apply electrochemical techniques to biochemistry, microbiology, biomarkers, biology.
We are using electrochemical methods to study biological systems, from DNA to proteins to bacteria to tissue cells to cancer cells.
Our work that was just published serves as a proof of concept for detecting and quantifying cytochrome C oxidase deficiency. It's the oxidase protein that's essential for energy production. So when that protein has an abnormality, isn't working well, it's obvious you're going to have some major organs with abnormalities and that are not working fine. So we're talking muscle weaknesses, heart, liver, and kidney problems. And because of its hereditary nature, it affects kids and infants. And so currently, this disorder is being diagnosed through clinical tests and muscle biopsies, which are not only invasive, but time-consuming and expensive, resulting in a delay in diagnosis. And this is exactly why finding a quick, inexpensive, and early means of diagnosis is essential to minimizing symptoms and preventing long-term disability in young infants. And that's exactly what this project has the potential to do. It serves as the foundation for an electrochemical sensor that can be developed, where we use the cells, let's say cheek cells, where you can take a cheek swab and in one single cell, we can tell whether a newborn has this deficiency or not. And that prevents the parents from feeling all the emotional anguish that's caused by the waiting and the muscle biopsy. I honestly didn't know much about how to get involved in research when I started my first year, but I knew that was something I was strongly interested in. So I think on my Instagram, I saw a lab track, which was advertised by the Science Students Association. So they basically walk you through the entire process from applying for awards. And that's when I knew I wanted to work in chemistry and approach where it's applying chemical techniques to biology. I knew I wanted something that was not just one subject. So that's why I was drawn to Dr. Spienkus's lab. But what's been the highlight for me is the people.
The group dynamic in a research team is extremely important for productivity, but also the well-being of students who are under an enormous stress. I always tell students the time as a PhD or master's student is one of the most difficult times or stressful times they will encounter. We are open to students regardless of how they identify. We have individuals that are Indigenous. We have individuals that belong to the LGBTQIA2S+ community, and many that started in Canada as international students.
Dr. Kuss is an amazing PI. The mentorship and the guidance and the support that she offers is the best. It's the kindest group of people you're ever gonna meet. It's research. There are gonna be days where the experiment doesn't work, or things are not going your way. And the group supports you.
Our team is built on a close to non-hierarchical structure. So that means that knowledge is shared. Personally, I do my best to adapt to the needs of each individual student. It is immensely important for undergraduates to get research experience as early as possible. 3 main reasons. So first, it creates a sense of belonging. Then it helps students to understand theoretical principles. So not everyone learns in the same way. And then it helps students, of course, to understand where they want to go. There are a variety of opportunities that undergraduates can pursue to engage in research. Most students start by applying for a summer research award. Then there is the co-op program that provides the student the opportunity to engage for a full year in different or the same placement and conduct research, not just in academia. They can also do part of the program in industry. And then there's the honors project. They're being trained in other skills than labs.
Being part of this undergraduate research program is really an incredible opportunity. First of all, I felt really inspired by what I was doing, and it's a very different feel that you have being in a lab like this compared to academic. And you get to work on something that's a lot more practical and has applications to the real world, which is really exciting. And also you get to learn a lot of techniques and skills that you probably wouldn't I think it's great to expose yourself to a bunch of different opportunities. And even if you have your heart set on one thing that you might want to do for your career, it's a great chance to just see what your professors actually do.
This summer research program allows us to have the opportunity to get comfortable, explore research, explore our interests, and channel that into a research area.